Welcome to my channel. So I will discuss limits of multivariable function. In the previous lecture, I have discussed function of two variables and domain and range. So first of all, let us take some example and we find the domain and range, and then we will discuss the limit of multivariable functions. First we take f of xy equal to root over x minus y square. So we will find domain of this function and range. So for this domain, we first, this is a function of from x cross y to r. This function goes to r, so this need to be a real number. So it will be real if and only if this greater equal to 0. So domain would be set of all that points x comma y from R2 such that x minus y square greater equal to 0. So this can be simply written as those x comma y from R2 such that x greater equal to y square. This is the domain for this function, and range as this goes to r and root over x square minus y square be greater equal to 0. So range will be from 0 to infinity. You can note down. Now I discuss some properties, so we will use later in limits of multivariable function. So first of all, a point x0 y0 of a region S in the xy plane is called first an interior point. If there exists a disk centered at x0 y0 that contained that entirely contained in S, and a boundary point, if every disk centered at x0 y0 contains points that lie outside of S as well as points lie inside S. So clearly this x0 y0 the interior point of a region S in the xy plane. Let us take x0 y0 point is this. So and disk centered x0 y0. If this disk, this is important, there exists a disk. If there exists a disk centered at x0 y0 that entirely contained in S, then we said this point is interior point of this region. So let us suppose this is region S and one element x0 y0, and if there exists a open disk which is entirely contained within this S. So from this point, if we choose this point, we cannot find a disk, that is there exists no such disk centered at this point which entirely contain this S. So in this case it contains some points from this set and some points which does not contain in the set. So this will be interior point of the set and this will be boundary point of the set. So that's it. And region, so open region and closed region, we will discuss open region, closed region. Open region, if a region contains all of its interior points, then this region is called open. And closed, if a region contains all of its boundary points, then it's called closed region. So let us give some example of closed region, open region. So let us define, this is set. So this is a equation of circle. If we x square y square equal to 1. So if we define a region that contains all those points xy from R2, that is xy plane, such that x square plus y square less than 1. So if 1, then the points on the circle, and for this set those points which are inside in the disk. So if we choose any point, so there exists a disk centered at this point which entirely lie within this. As the point on this line does not contain this set, so there is no problem. So it becomes open region, that is open set or open region. This is open region, and if we choose this set as x comma y from R2 such that x square plus y square less or equal to 1, that is all points within this circle and those points which are on the circle. So all points contains within this. So here points on this line are all boundary points. All are boundary points. So this set contains all of its boundary points. As this is less or equal to, so when x square plus y square equal to 1, then the all points on this circle contained within the set. So this set contains all of its boundary points. So these are boundary points. Boundary points means a point every disk centered at this point contains some points that lie outside of this region and some points here from here which lie within the set. So all of its points contained in this set. So this set is closed region as all of its boundary point contained in this set.